Hi guys, today part 1 of the teardown of this. So this huge item on my bench is a French-made infrared spectroradiometer. It is an item that was on eBay for a long time and I have been watching it for long, but it was too expensive. Finally the seller lowered the price and I was able to get it at 50 euros, but sadly it seems it got some storage and moisture damage in the meantime, and it is not really good anymore, in particular because of some corrosion of the aluminium and corrosion damage on the main very special filter wheel. So it comes with this huge rack box, which is actually half empty, and a few accessories. So today we will have an overview at everything and a look inside this power supply box, because it is just 3 modular power supplies on one interface PCB. It should be pretty fast, I guess, to do, but taking apart the main unit is another deal. It came with, as accessories, a stupidly stiff and short link cable between the head unit and this box, which will allow you only to use it in one particular position, quite well. It comes with an extra lance. So here on the front we have a very big casse-grain lance, but it comes with an extra one here, 143 millimeters of focal distance, 1 degree angle it seems, serial number 5. So casse-grain lance made of 2 mirrors, but actually the cap at the back is quite difficult to undo. So just like telescopes or missile infrared seekers. So a cute little one here, in a new condition, this one, because obviously it was an accessory that was not fitted. Instead they did have this big one. So first we will have a look at the front panel here on the details on the camera. The infrared spectroradiometer, not the camera. So this big box is just power supply and interface card. We have plus and minus 15 volts, but the plus 15 is not working, plus 5 and plus 24. We have here what looks like a NATO number and a warning: do not switch on without liquid nitrogen. We have LEDs for running status and output BNCs apparently. The other half of the box is empty, and it comes in a big cabinet for hosting the rack module, but it could be mounted in a regular rack also. So if I undo these 2 screws, we find out 3 modular power supplies. Well, you do not see anything in fact because it is too dark. We have here just wire looms on the front door with some loose wires here. The power supplies, we will take out them later. And there is this computer interface board here that could be extracted like this, but really the latch mechanism here is completely stupid and broken, and it is even worse on the power supply modules, because when you want to reinsert the card you have to pry out the other way the 2 sides, and it will prevent you to see where is the slot actually to put the circuit board. and really not a good design, but you do not see much because it is too dark. And spoiler for you, here is the board. Okay, so if I close this and turn the box on, which is already super heavy, we have at the back, excuse me, I will grab a light. So, the, better maybe like this, parallel plug for computer, the plug to the main unit. Your BNCs, I do not know if they are outputs or they must be connected to the main unit. We have a super noisy fan, we have mains input, and we have a sticker with model number and serial number C001, made in February 1988. Okay, now I will just demonstrate you the very short cable and I will remove the rack from the box. So this very short cable will only allow you to use the spectroradiometer in this orientation with front panel of the rack here, because you can only connect it like this. Actually, as it is super short and stiff, you cannot do anything else. So it is a really weird setup, because it will not allow you to put this on a good stand or anything like this. So maybe it is more for testing purpose of a device than something else, real use. Quite weird and quite in bad condition also. And I will just figure out, I was totally forgetting about the main unit. So we have this big aluminium thing called Ingénierie Systems Infrarouge in French, so infrared engineering systems in English. On the top we have a fill cap for liquid nitrogen, just like on the AGA thermal camera I have. We have a viewfinder here, optical viewfinder, that is activated by a lever here. On the back we have the plugs, and we have a sticker with a license from ONERA. It is the French National Organization for Space Aerospace Studies. So quite interesting. All the sticker also. On the bottom we have a big mounting plate in some kind of plastic. The Allen screws here were super tight, and there is a model manufacturer sticker here at the back, but it will require removing this plate, so it will be for the next part of the video. And we have in front the very big casse-grain lance with, excuse me, so will you see it? Quite impressive thing, with serial number here 003, 500 millimeters of focal distance, and the big Allen mounting screws. The cap over it is a thick piece of plastic, machined plastic, quite impressive, with this red flag like onto aircraft protections you need to remove before flight. And it is not all, because the device came with a user manual. Well, actually a repair manual with mainly the schematics of the circuit boards, but it is better than nothing. Okay. Now I will actually remove it from the rack. So I will undo this rack from the housing. It will be easier to have a look at it. And then I will mount the camera overhead and we will be able to have a good look first at the manual maybe. So it is used, it comes from the French army, in particular the headquarters responsible for weapons development. So I believe it was used for tracking missiles, hit signatures of missiles or aircraft or camouflage equipment or something like this. Okay, excuse me, I have to pull on this thing, try to, or push maybe from the back. Okay, well, as you can see, it is not easy because okay, and then there is something else. In fact, it is, yes, very tight fit and you need to pull it straight, if not it will not come out. Not terrible design here. This thing is actually a mix of super expensive and cheap design. Okay. Excuse me. You get the idea. It is super deep. And here we are. So I will get rid of this empty box for now. Install this on my bench and we will be able to do something from here. So I am back. Here is how this rack is constructed. Big aluminium plates on the sides, big added piece here with a very noisy fan and air duct to conduct the cooling air to the free off-the-shelf modular power supplies, some wiring loom to distribute the power and signals, backplane connectors here, and your regular rack mounting stuff. The front has the panel I did show you here earlier, and here nothing. This is for mercury, cadmium, tellurium, actually the composition of the sensor in the instrument head. So, but before I will show you just one of these power supplies because there are nothing interesting. But first, look at the manual. If I can get this out of the way. So it came with this manual, which has all the schematics, even including the drilling patterns of the circuit boards, quite unusual. So it is called the spectroradiometer infrarouge, infrared spectroradiometer. And here is the information in French about it. So it says it will measure the spectrum of heat source more or less at a distance. So here you can see the device mounted on something very impressive that seems to be a turret for missile tracking or rocket tracking, something like this. You have this instrument with probably here a big hose to bring liquid nitrogen in it. You have other thing here with a wiper on the front, on the bigger device here, but it is not possible to read really what it is written on it, but this must be really huge. So it can be used in aerospace for pollution, planetary studies, atmospheric studies, agricultural purpose, geological, things like this, but most important, military. So spectrum of signatures of weapons, engines, countermeasures, camouflaging, atmospheric transmission, and spectral emissivity. So here they say it use rotary interferential filter, which is a very important piece but damaged in the camera, in the device sadly. Some information on what it can do. 30 spectrums per second. And it is interesting to note on the photo here that the lens in the photo has serial number 4. Mine has serial number 3. And it is made to be connected to a computer, very old school, classic IBM PC, obviously. Here, information about some specifications, but really not a lot of them. So the sensor is indium, antimonium, mercury, tellurium, cadmium. We have a reflex viewfinder. No germanium in this device, only optical mirrors, it seems. And some layout here of contents. We have the main lens at the front. Your reflex viewfinder you can swap in and out. The rotary filter. Black body reference. So it is actually a piece of black aluminium with Peltier cooler. Another internal lens and your sensor with DWAR for liquid nitrogen, just like on the AGA thermal cameras. Information about the manufacturer, and it was made under license for the Direction Générale pour l'Armement, so DGA in French, or Weapons Headquarters, responsible for all kinds of weapons, in particular special weapons. Here we have a lot of sheets with parts list, circuit boards. We will have a look at only one for now, what they call the reception card, which is actually the one I did remove earlier from the device, this one. So we have on here a prom which was not covered by black tape, oddly enough. And we have the most important parts are this Burr Brown ADC 80, more Burr Brown chips here, and here this special case operational amplifiers, very thick and unusual. They are worth something like 25 euros each. And there are these devices on the schematics. Some bodge here where they did add a CD 4081 chip on a Vero board with some bodge wire. And it is all for this board. Nice golden backplane connector made by Panduit. And a lot of trim pots actually on this thing. So it takes the signal from the main sensor head connector here, and it will output here in on a DB connector to the computer probably. I think you will need another interface card in the computer also. Yes, most probably. But you have your data lines and some control lines. In particular, one for reflex viewfinder, ready, and TOF environment signal. Quite interesting. Okay. So it was this. Now I will just extract for you one of the power supplies, because they are regular off-the-shelf power supplies. Nothing fancy. And you will see how hard it is to undo one. So the first one here, you have to press on the top and the bottom at the same time and you have nothing to grab the power supply, actually, no handle, nothing. And when you get those things out of the way, you can try to pull on the very hard backplane connector. And it is really not easy. Where is it, this one? Here we are. And reinstalling is even worse, trust me. So we have this power supply module with a nice heatsink on it. Linear power supply with a transformer, big filtering capacitor as you can see, but nothing special except these golden standoffs to connect the power transistors here. You can see at the bottom. Big bridge rectifiers. Quite a weird looking fuse, but this one is actually good. 2N3055 transistors. Your backplane connector here. And so on this one it is more or less broken, but on the other ones the plate is in good condition. You have a schematic and a pinout. So it is a Schrott Power Pack PSM Dual, but really off-the-shelf stuff they did use here. Quite compact and heavy device. And here maybe I can show you what looks like the backplane connector at the back, but the wires are completely hidden by this air duct for the fan. And this is actually all what we have in here. So now I will try to get the opportunity of a good light to reinstall this thing. It is really not easy because you do not see, because of the red plastic part here, you do not see where you are in the slot and if you are correctly engaged or not. Okay, it is done. And now I can close this door. So considering it is not working correctly, it is very bulky. And as you will see in the next video, the sensor head itself is in bad condition. I do not know what I will do with this stuff, but it might end in parts, at least for this cabinet, because I do not really need it, as I do not plan to use the spectroradiometer anytime soon. I will also install this. So this one is a little bit easier because of the levers on the front, but still not the best design. As you can see, I try to. It is really a pain, these things. And they are brittle and they break in parts also. Here we are. So this one is a little bit better to reinstall, but still not terribly good. And now I can have fun at reinserting this in the main black and red cabinet. Quite interesting. One last detail maybe. Very nice quality BNC plugs here with this plastic flange at the back. Some unused or modified connection here. Little cap here. Grounding here on the screw. Interesting, but this is seems to be almost a homemade thing. Not super impressive. A bit how you do in particular for the added part here. They did not do this part long enough or something like this, and they had to add very thick machined aluminium plate here, but why they did not do it directly from this part, I do not know. Okay, and the fan is super bad, believe me. So I will put this back together and stay tuned for the next part of the video, which will be taking apart the main sensor head, and believe me, considering the number of screws, it will be quite something. So thanks for watching, bye bye.